Yep. So this session is going to be about the open policy agent. So the agenda for this session is like we'll start with the challenges with the traditional authorization methods like the access control lists, the role-based access control, and attribute-based access control. And then we will see the recent development in this authorization domain, which is the introduction of the policy-based access control authorization method. And then we'll see how OPA provides an implementation of policy-based access control and then introduce OPA to you. Then we'll see a demo with a sample to-do checklist application where we will enforce some authorization policies dynamically and see what effects it creates in the application. And then we'll briefly touch upon the Rego policy language, which is the official like a policy language used by the open policy agent to define the access policy as code. And then we'll do another demo to see how message delivery makes use of OPA to provide authorization. So basically, I've mentioned the word policy several times. So what is a policy? Let's start from there. Policies are basically any requirements, legal requirements, or business constraints, or in domain-driven lingo, it's a domain invariance, right? That must hold true at any point in time for the system. So it cannot be violated. So it must hold true at all times. It's basically some requirements or constraints that must hold true. So any access attempt that violates an enforced policy, that access should be denied. So that's what we mean by policy. So here are some examples of policies, and these policies are usually defined by the business people. For example, let's take the demo application, which is basically a to-do checklist application. You can easily imagine business giving a policy like only project managers or users who play the role of project managers can add to-dos or delete to-dos or edit to-dos or mark to-dos in this application. That's one example. And for example, the settings is something that only project managers and administrator can change the settings. That is also an example of an access policy. And another example is, let's say, only supervisors can view the timesheets of employees reporting to him or her. So these are some examples of access management policies. But generally, policy can mean anything outside the access management also. Like, for example, some discount policies on in the e-commerce website on certain products. Even they can be some access policies. When they are enforced, they must always hold true. So let's look at the challenges with the traditional authorization methods. The access control list, abbreviated as ACL, is a primitive method of doing authorization, and probably it might not be enough for the authorization needs in the modern application. The next evolution in the authorization methods is the development of role-based access control. But even though it is widely used today, it still has inherent problems like the role explosion problem, which basically means there are too many number of roles, and it becomes difficult to manage those roles as the organization grows. So the scalability is a problem with role-based access control. The policy is defined as role definitions, and it is coupled to the source code. So what a role can do, that is usually tightly coupled to the source code, and any changes to that policy will require rewriting the code and recompiling, redeploying, all those things. And the config is not dynamic. Like if there is a need to change the definition of a role, we have to update the source code and redeploy it. The next step in the evolution of the authorization methods is the attribute-based access control. And attributes meaning like it can be the attributes of the user, or it can be the attributes of the resources being accessed. So based on that, the access control is defined. XAML is one popular language which can do the attribute-based access control. The drawbacks with this is like, compared to JSON or YAML, usually developers find it difficult to comprehend. I mean, relatively more difficult to comprehend the XML. There is no provision to test the policies with automated unit tests. And also the policy evaluation speed is slower compared to the recent solutions in this authorizations domain. Here's an example of the attribute-based access control, extended access control markup language, XACML policy. As you can see, it's difficult to comprehend because it's you have a lot of fully qualified namespaces, and it's difficult to see at a quick glance what this policy is. Just that's why they have the description here to describe what this policy is. It says that policy denies access if last login is more than 30 days away from today's. So that's the policy, and this is what the policy is. So it's obviously it's difficult. So that paved the way for the introduction of policy-based access control. And generally, a policy-based access control system has these characteristics. So this is the most recent development in this authorization domain space. So it provides the system should be able to provide fast evaluation of policies in a separate service. The policy should be it should provide dynamic update of policy without requiring any rebuild or redeploy or reboot of the services. It should allow the use of some declarative programming language to make it easy to define the policy. It should support unit tests to validate the policies, and it should be allow us to define fine-grained and complex authorization policies. So these are the characteristics that a PBAC system should have. So I'll hand it over to Sabrish to explain in further detail what a PBAC is and introduction to OPA.
Thank you, Shakti. I'll quickly share my screen. Okay, so are you guys able to see the screen?
Yes, sir.
Yes.
Yeah.
Okay, cool. So we just learned like what is the characteristics of PBAC system, right? So let's have a look at PBAC architecture. Okay, let's take a sample. Let's consider a sample application where we have like the user, the backend, and the database. So the user makes connect to the backend to asking for edit record, and then the backend will obviously will fetch from the database and then like give it, and this flow continues. This is a normal application scenario, right? So in a PBAC architecture, the backend acts as a policy enforcement point. So it basically enforces the policy which we define. So then in that case, what will be the next step? So it doesn't make any decisions on the policy. So that means it is just an enforcement point. So in that scenario, it will connect with another point called the policy decision point. So this decision point is the one which makes the decisions of the policy. So for example, when the backend asks can user one edit the record for the particular record, then the PDP will evaluate the policies and then return whatever the decision like permit or deny something like that, and then the flow continues in that aspect. So this is this is a complete independent process. So for this PDP, there is another point called the administration point. So this PAP, this is a separate system, a separate service. You could say a separate service. So this feeds the PDP with the policies. So whatever the policies from the business we get, so this is fed by the PAP to the PDP. Similar to the PAP, we have another point called the policy information point. So this PIP is something which feeds the PDP with additional information. So probably some information that may be required, to evaluate the policies. So this the PDP will be together analyzing the policies and the information to to result up in some decisions. So and as I said, so this is like separate independent process, and this one is also a separate independent process. And in this PBAC architecture, where does the OPA fit in? So OPAs basically fit as the policy decision point. It becomes the decision point in the policy-based architecture. Before we see the features of OPA and how does it fit in the PBAC, let's quickly understand about what is OPA. We have a quick intro on OPA. So OPA, or Open Policy Agent, right, is actually an open source developed by the cloud native community, and it is a general purpose policy engine. So it is like a logical engine which computes and gives some logical decision, makes some logical decisions. And for that, it uses a language called the Rego, which is a high-level declarative language. And this language helps us, to define policy as a code. So how we make a how we write a logical programming code, so we can write the policy similar to that as a code. And this helps us decouple the policy from the service it governs. So the policy governance is separate, and the service will be running separate. So so it is decoupled. And also the policy update happens independently. So there is no need for rebuild or redeploy neither the service nor the OPA engine, OPA service, to make the policy changes reflect. And since it is a code, we can make unit testing on the code. You can even do test-driven development on the code as well. And the evaluation of the policy is very fast and efficient. So the fast in the sense, policy evaluation might take few milliseconds, probably even at some cases less than a millisecond. And efficient in the sense, the memory, or the load taken by the OPA service is very small. The only load will be the data which we give it to through the PAP. So in the PBAC architecture, so we said OPA is acting as a PDP. So let's consider a small example, right? So probably a service. So the service could be, a middleware, or a servlet, or any service for that matter. So this service will get some input request or events, and for this particular request or event, the service will in turn contact the OPA with a specific input. This input is any JSON value, so it will be in the format of a JSON. And for this particular input, the OPA will be make some computation, and it will return the decision for this. So this decision, if you see here, like it could be any JSON value. So it is not arbitrary value like true or false or allow or deny. So this is you could even produce it with a list of details as well. And in the PBAC we have a separate PAP service and separate PIP service. So this PAP service will fit with the policy, and this policy will be written in the language Lego. And this additional data is also a JSON value. So this data here from the PIP and the input from the PEP, these two are considered as inputs from the outside world to the PDP, right? So these are called as the base documents. This base documents, along with the policies evaluation, will result in the decision. And this decision is known as virtual document in the OPA context. Okay, so let's quickly see, where we can do a PP in the service. So in a typical, let's consider a typical sample example, right? So we have a client which connects with the API gateway, and then to the backend, and then to the DB. So for this service, we have OPA sidecar running alongside. So this OPA sidecar, will have frequent dynamically changing policies which are updated, asynchronously. So for this service, we can implement, the PEP at multiple places. For example, at the API gateway level, you can have, routing decisions for a particular, API call, something like that. We can have it implemented at that level, or even the backend service for authorization, right? Whether a particular person is having a permission for a particular resource. So in that context, and even as in the beginning, how Shakti said, even in business decisions, like for example, e-commerce website could have a business decision of like what kind of discounts, or like what is the price, or coupons which can be given to the customers. So these things can be independently updated in the policy engine, so that there is no need to redeploy the service or redeploy even the OPA sidecar as well. And next one is we are going to have a demo, and this is the architecture of the demo application which we are going to see. So in the demo application, we have an end user, and the application is basically a single page application. So the end user, connects through a browser and communicates with the backend service. And the backend service, in turn communicates with the OPA sidecar to make some decisions. Basically like whatever inputs we get from the user, the backend service will connect with the OPA sidecar to make a decision and then do the needful and then return whatever data to the user. So this is on one side. On the other side, we have the business teams and the development team. So the business team will give the development team with the access policy definition, right? So let's say we have a new updated policy or something like that. So the business team will be giving that to the development team, and the development team will be making the changes in effect in the Rego language, and it updates the OPA service. So the part, so as I said earlier, so if you see, so this is a independent process, and this is another independent process. So the application is running aside, and the policy enforcement is running independently. And Shakti, you can take over for the further.
Okay, thanks, Abrish. So yeah, so we'll be implementing an example policy, access policy. So before that, we'll have a look at the structure of the access policy. What are the components that makes up an access policy? So here is one example. Only project managers can add or delete, edit or mark to-dos. And here it has three main components. One is the user, who is this project manager, and the action is one of these actions, add or delete or edit or mark complete, and the resource that is being updated is a to-do. So user, action, and resource are the three main components of an access management policy. And here is how it looks in the Rego language. So I'll explain this in the demo. Let's quickly show you the application. Okay, so this is the one example applications that we have used to demo OPA. It's basically just a front-end application, and it's written in React.js. So it has a list of to-dos, and the logged in user is alias good, and the logged in user can perform any actions like deleting the to-dos and mark the to-dos as complete or not complete. And there is option for delete all to-dos, and there is some settings that they can change. So these are some actions the user can perform in this application. And we have like three different personas here for this demo application. It's basically a checklist, to-do checklist application written in React.js. And the user personas are Alice Good is a project manager from team 1. Bob Honest is a project manager from team 2. These are the users of this application. And Mallory Bad is a developer from team 1. And mostly I'll be logged using Mallory Bad as the persona for this demo, because she will attempt to do something bad or unauthorized. And we will enforce access policies to prevent her from doing those unauthorized actions. So the initial policy is that that is in effect in this application is anybody can change the to-dos and view and edit settings. Let's look at Mallory's login. So Mallory is logged in now. So she can mark this as complete, and now she can delete this, and now she can add to-dos, and she can change settings. So Mallory is I mean, anybody can do anything right now. So now we will enforce this policy. Only project managers can add edit and delete mark to dos. This is the input that the business team gives to the developers, and the developers have to write this as Lego code and update the open policy agent service with this policy. So let's do that now. So I got that requirement from the business. I'll take this. This is a one policy that enforces that requirements. So basically, this is the part I would like you guys to focus on. So this is the policy name, and these are the conditions that must be met so in order for the policy to take effect. And there are two rules. One is the project managers can add, modify, and delete to-dos. And the next rule is anybody can view and edit settings. So let's apply this policy on the OPA service. So for that, I will use Postman. OPA exposes REST endpoints to update the policy. This is the initial policy. I'll delete this, and I'll update the policy in OPA. So let's update it. So now the policy has been updated. Let's try to access that, see if Mallory is still able to edit or delete. See, so now the policy has been enforced. Here, one thing to notice, for every action, the application sends a request to the backend service to check whether to allow this action or not. And then only it will, depending on the decision returned by the service, it will enforce. So the application itself is the policy enforcement point here. For example, I'll try to delete here. Yes, so there is a request, and the response for that is deny. So that's how it is enforcing the policy here. It's just querying the decision point and getting the decision and enforcing it. Meanwhile, like the other users, for example, Alice can still mark these things as complete, and she can still delete things. So the access is denied only for Mallory, because as per the persona, Alice is a project manager, but Mallory is not a project manager. Okay, so let's go back to the slides. Okay, here there is one more policy which I can showcase using the test-driven development. Let's say next the project, there is a requirement coming in from the business team that saying that only project managers from team 1 can view or edit settings. So according to this policy, only Alice will be able to edit the settings. Bob and Mallory will not be able to edit the settings. Let's look at right now the policy is not defined and enforced. Still, Mallory can still edit the settings. So let's write this policy and enforce it. Okay, so here I have let's do it in the test-driven development way. Let's assume that this is the initial or the second policy is in effect. Let's copy this. This is the second policy, and I'll write the test for the third policy. Even the tests are in a Lego language only. Okay, so let's run the test now. The test has been updated, but the policy is not yet updated. So running the test is as simple as running this command. So as you can see, there are several couple of rules that are failing. So all the tests are basically rules that start with the test underscore prefix. So even the tests are written in the Lego language. So now let's update the policy such that the tests are passing. So here the updated policy is says that the project managers can add, modify, delete to-dos, and the team 1 members or the project managers from team 1 can view and edit settings. So these are the two rules in that will update. So let's rerun the tests now. So now the tests are passing. That means the policy is defined correctly and validated. Now it's time to apply this policy in the OPA service. take this, and I use Postman again. Just to remind, OPA exposes APIs to update the policy, and just send this. Yeah. Now the policy has been applied on the service. Let's see the effects, if it has any effects. So now I'll just click the settings. Now Mallory is not able to view the settings. Whereas if you look at the other personas, Alice is still able to access the settings and edit it. And Bob being a project manager, but he is from team 2. So still Bob will also may not be able to edit the settings. So that's how the policies are defined and enforced. Okay. Okay, that's the demo application. I'll hand it over to Shaktivel for the next section.
Thanks, Shaktidharan. So before we continue, right, we'll take a pause to see if there are any questions.
I have just one clarification. This is Sunit here. Same validation can be done on the server side as well to save one extra round trip, right? Since your application is just front-end application right now, I guess you're making the authorization call, correct?
Yeah.
Okay.
Yeah, ideally it should be done the the validation or the enforcement point, should be done in this backend service.
Yeah, and in the backend service, we have a sidecar running, so it will be cached and all. Okay, perfect.
Yeah, yeah.
Yeah, I think we can proceed if there are no questions. Hope my desktop is visible. All right, so let's probably, I think it was a good demo to see how the access was managed in a web application. So in this part of the session, we'll talk about how OPA was leveraged in the event-driven architecture. So the main purpose to implement OPA and event-driven architecture is to manage the attribute-based authorization for the events that are getting delivered. So before we dive in, let's probably talk about what is meant by event-driven, right? So there is a good article published by Martin Fowler. But for the sake of the session, so event-driven is a way for different services to communicate with each other with the help of an event. So event can be a message notification which carries information about something that changed in a system. If we take an e-commerce domain as an example, right? So the order that is getting created can be an event. So with the help of that event, the subsequent business workflow can start and trigger and can continue. And if you take an example of a version control system, right? A commit that is getting added or a commit that is getting created is an event. And the pipeline that is listening to this event can start and build the pipeline, and it can go on. So usually in the event-driven architecture, we'll have a publisher. So the publisher will be publishing messages to the message broker, and the subscriber will be listening. So if the subscriber is interested in the change in a particular system, so they will voluntarily subscribe to that event, and they can start processing the message. So the main advantage of event-driven architecture style is the decoupling. So as a publisher, I will let the message broker or the message router know that something happened in my system, and I don't care anything about which subscriber is subscribing to or which subscriber is accessing. So which kind of creates a decoupling, and which is very helpful in scaling large applications. So when we take an event as an example, right, the event should always be immutable, meaning it's kind of a fact that happened in a system, and it cannot be changed. It cannot be it cannot be changed, and it should always be the sequence of action should be in the order. I think that's with the high level introduction to event driven, and multiple publishers can publish to a message broker, and multiple subscribers who are interested in certain publishers can record their interest and they can start consuming the events. One other example, considering the banking domain, is let's take an example of an account created. So as a customer of a bank, an account is getting created and an event is triggered. And we can imagine different services listening to that event. So we have credit card service, which needs to decide whether a credit card should be mailed to the particular user, the customer. And we have a net banking service, which needs to decide whether this customer is eligible for a net banking activation. And we can also have a DMAT service, which decides whether a DMAT account can be created. So all these things, right? So if you see in this publisher side of things, so it needs to notify that an account has been created, and these services can decide whether they wanted to listen and process. So usually the logic will be there at the service level. For example, the credit card service will be listening all the accounts that are getting created. So even though for certain set of accounts, the credit card need not be sent, so there will be business logic in the credit card service to filter out the events which are not eligible for credit card. That goes the same for all the other services as well, right? Imagine enabling an authorization for this kind of an architecture. So the account created system saying that only for this specific set of accounts, the credit card service should be consuming and processing the events. And it can also say that only specific set of accounts can be processed by the net banking service. So it goes on. And this is for a single domain, right? If you take an example of an organization similar to ThoughtWorks, so we have different set of domains, subdomains within the organization. So we have finance domain, we have people domain, we have staffing, dealing with all the staffing related things, asset management, dealing with managing the laptops, the assets within the organization, procurement, demand and supply. So these many subdomains are there, and the event driven architecture enables ease of communication between different subdomains. And the major challenge would be for all these subdomains, right? So each system should be in a position to manage authorization. So one example that we can probably talk about is, let's say we have this demand and supply domain, which says in next 15 days or in next 30 days, there is a new account that is coming in and we wanted to staff 30 members. And the staffing domain will be listening to this, and the staffing can take decisions whether are there folks available to be placed into the account. And similarly, if are there enough assets, laptops that are available in the inventory, and should I be procuring more? So all these things will be taken care. So this is kind of a hive mind, right, where different subdomains are interacting with each other and taking business decision to continue the business. And the message broker can be anything. So it can be Kafka, it can be RabbitMQ, or it can be Amazon Kinesis, or it can be Google PubSub. So the messaging broker can be anything. But to manage authorization across all these subdomains, we might need a centralized authorization system. So that's a major goal, right? So if you are able to manage authorization at a centralized place, all these subdomains will continue to do their business, given that the authorization is managed at a central place, which also reduces the maintainability at each subdomain level. Okay, so coming back to the fictional banking domain, right? Let's say there are a set of rules for the credit card service to be activated based on the account type and customer type. And similarly, there are a set of rules for net banking to be activated based on the customer and account. So imagine in this fictional banking, so we have different types of customers. So we have premium customers, we have preferred customer, we have standard customers. And there are different types of accounts as well. So max savings, savings plus, and regular. And the business comes up and say that the net banking should be activated or enabled only for the customers who are either premium or preferred. Similarly, if their account is of max savings or savings plus, meaning if they are a standard customer and if they are a regular account, then the net banking should not be activated. And similarly for credit card, right? So any premium customer, automatically a credit card should be dispatched, and account doesn't matter. And the insurance domain can come and say, look, if it is a premium customer, and if the account type is of max savings and savings plus, then I will be providing a free insurance to the customer, and the insurance should be processed. And this can change frequently as well. Within a week, right, the business can come and say that I need to remove preferred from the list of customer types. So the net banking should be activated if it is only a premium customer. So it is very dynamic and it might evolve. So for this kind of use case, right, we'll quickly check how OPA can be helpful in making the decisions. Before we get into that, let's take a quick look at the event, right? So this is a sample event which is created from the which is the account created from the banking domain. And if you see here, so there are two attributes, so the customer type and the account type. So which is the information that we will be using for deciding whether the net banking or insurance or the credit card service should be receiving this event. So this is the attribute based access control, right? Based on the attribute data, we are deciding whether do we need to process or not. And a quick refresher to what we saw earlier. A request can be an API request, it can be an event which is coming into the service, and we will be defining a policy. So the policy is the administration point which will ensure that the data and input that is coming in are processed together, and the decision point will decide whether to allow processing or allow or deny, basically. So if you think about this, right, so this is the decision point, OPA is the decision point, policy is the administration point, and data is the information point. So the data is an interesting thing. So the data is what we saw as rules. So this is the kind of rules that the business came up with, and this can probably dynamically change. So that is what the data in OPA is all about. And the input is nothing but the event, the request, the account created event that came in, and the policy is what we will be defining. So we'll be writing the policy using the Rego policy language. And again, like so we are not going to deep dive into the Rego policy language, but we'll see a quick demo of how dynamic we can write a policy which will be useful for taking decisions based on the business context. I think with that, I'll go into the Rego playground. Hope my screen is visible. So this is a Lego playground provided by the OPA website. So if you can access the OPA site, so there is a playground available which has a good number of examples. So you can try out a lot many examples here. And we are going to take a look at the attribute based example. So in the attribute based authorization, right? In the attribute based authorization, so we have a policy defined. So this policy is the administration point. So this is a custom built policy or custom developed policy, which is going to evaluate the input and the data. The data is nothing but the set of rules that we have defined. So here I have defined the rules. Let's say like the services, net banking, credit card, and insurance are going to operate based on the rules that I defined. So here for net banking, I say, so if the customer type is not standard, then the net banking should execute. And if the account type is not regular, then it has to execute. So this operator, this field name, this value is all something that we came up with. So this is an arbitrary JSON structure. We can come up with any structure based on the business. So that's a prime advantage of using OPA. And you can also write anything. So the anything related to the policy, as long as the code that you are writing is compiled by the OPA language. And for credit card, I have defined a set of rules saying customer type in premium. Then I should send this event to the credit card service. And I don't have any other rules because if you remember, we saw on the list of rules. So the credit card can be sent if the customer type is of a premium. So I don't have any rules for account type. And this is what I have defined in my data. So similarly, insurance, we have a set of rules. So notice this part, right? The operator the operator is also dynamic. So you can come up with any type of operator. So I have defined the operators in the policy itself. So if it is in, then it should evaluate whether the value is available or not. If it is not in, then it should evaluate whether the value is not available in the list. So you can come up with your own set of rules. So yeah, so this is the rules, and the input which I will be providing it to OPA is the service name. So I'm saying for insurance service, this is the data. So customer is the customer type is of premium, and the account is of savings plus. If we take a look at the rules, so if the type is of premium and if the account type is of any of these two, then we have to allow the message to flow into the particular we have to allow the message to be flowing into the particular service. Let me evaluate. Right. I think I selected one of the thing and it wasn't able to evaluate. Yeah. So now if you see here, it says what are all the rules that are matched is that the customer is of premium type and the account is of max savings and savings plus. So it will say allow to true, which means it will not deny the request to be flowing into the insurance service. So now let's take an example of net banking. So I'm going to say the input is from the net banking, and so we have a set of rules for net banking, right? So it has to be premium. For net banking, it can be any one. That is, it can be premium or preferred, and also it can be max savings or savings plus, meaning the regular and the standard account. If either customer is standard or if the account is regular, then the message should not flow through. And let's say if I'm going to say the type as regular, and if we try to evaluate, yeah, it will say true. Okay. Yeah. So if we could see here, right? So the customer type is not in standard. I think I made a mistake. So the customer type is not in standard, but the account is in savings plus. So which will evaluate to false, saying the account type is standard for him, for which the net banking cannot be evaluated. I think this is more dynamic, right? So based on the business rule, we can define any kind of policy using the language, and we can also come up with any format of data. So usually this data will be changing. So we might be providing some abstractions, and we'll be able to allow the users to change the rules as well. So with that, I'll quickly go into why we chose OPA for attribute-based delivery in EDA, right? Like the main reason that I as mentioned, right, it needs to be externally managed, and it has to be very dynamic based on the business. So given that like there are different subdomains, and it has to be dynamically managed, and policy-based access control. So we will be able to write policies based on our needs, and we'll be able to deploy the policy, and the other systems will continue to work based on the value that is provided. And finally, the fine-grained authorization. If you wanted to go a level deep and have authorization at the attribute level, then definitely OPA is a good supportive tool for achieving that. Yeah, so I think with that, I'll probably hand over to Shakti.
Thanks, Shakti.
I had one question. What's the enforcement point for this? Is this also running like a sidecar to the service?
Yeah, so the OPA needs to be run as a sidecar, and it can be simple HTTP request to the sidecar to evaluate the policy. So the data will be loaded, and the sidecar can be used to evaluate whether it is allow or deny, and all the decisions can be done from that. Yeah.
Okay, thanks.
All right. So, so we'll talk a bit about the challenges we faced, or the things we learned when we used OPA. So the Rego policy evaluation works in a way where like all the rules are evaluated for a given input and the data that is fed into the OPA. All the rules will be evaluated. So we have to design the policy in such a way that exactly one rule evaluates to true for a given input. Like, if multiple rules evaluate to true for a given input, it might mean that the policy is not correctly reflecting the business requirements, or if none of the policies evaluate to true when the expectation is it should for a given input, then also it might mean that the business requirements are not correctly reflected in the policy definition. So we have to be careful when we design the rego policy such that exactly one rule evaluates to true for a given input. The next one is limitation that we faced, like when we tried to define the policies. For example, the rego supports only the existential quantification, which I'll explain with an example, and that does not have direct support for universal quantification. So for example of a universal quantification would be the first rule. Like, let's say there is a policy that we need to enforce which says that user must play all roles. All is the important word for universal. That means I'm referring to the universal quantification. The user must play all roles, like for example, project manager and time card manager, to be allowed to manage the time cards of project team members. So basically, we have to check whether the roles played by the user contains all these roles. This it's difficult to define this in the rego policy, because it's like for all the roles we have to ensure that each of the roles is present in the user roles attribute. So that has to be rewritten as in an equivalent way, like there should not exist a role in the roles array, like this in this array, that is not played by the user. So basically we translate this universal quantification into a negation with an existential quantification. So both are equivalent. So rego only allows us to write rules in this manner, in this manner. So that is one of the constraint right now in rego. And obviously we saw that only developers can update the rego policy, because it is code. Even though it's a high level declarative language, it is still code. We might need to build more abstractions on top of this to help to enable the business people to directly update the rego policy. Maybe build some kind of an interface where we take inputs from the logged in business user, and that inputs get translated into the rego policy and get applied in the OPA engine. So that those kind of tooling and abstractions we can build on top of what OPA offers us. And another thing we learned that was OPA does not support CORS. That's why OPA by design is supposed to be not supposed to be accessed directly from the front end applications. If it does that, the pre-flight request checks will get rejected by OPA. So there must always be a reverse proxy which the front end needs to access, and the reverse proxy will in turn access the OPA engine and get the decision and return it back to the web applications. So directly from the web applications, you cannot access OPA because it does not support CORS. So these are some of the challenges we faced, or some things we observed when we did this POC. Yeah, that's about it for this presentation. Any questions?
Yeah, just one question regarding this event-driven system. So this OPA sidecar will lie with the message broker?
It can be external as well. So the message service, before delivering the message to the subscriber, it can call the service based on the configuration. So let's say a particular domain, procurement in this example, right? If the procurement needs to define as a publisher, the procurement needs to define certain rules that only subscribers who are matching to this rules will be able to read the data. So in that case, they will be adding that configuration, and the message broker, if there is a configuration available, can call the OPA as a sidecar, and it can evaluate whether to deliver the event to this particular subscriber, and from there it can either deny or it can allow. So to your question, it will be running it as a sidecar, and the message broker will be contacting the sidecar to decide whether to allow or deny.
Okay, yeah. So is it a good practice to have a procurement service to define the policies?
So here the journey is the publisher defining the authorization rules. So the publisher needs to enforce the authorization that only certain parties should be able to listen and should be able to process it. For example, there might be cases where there will be personal identifiable information, or there might be cases where only a particular region needs to get the data and process it. For example, if there are information for India region, then the subscriber should be able to process only the events, and they should not read events related to a different region. So in those cases, the publisher can enforce the authorization in such a way that the subscriber will receive only events related to the India region. It is a business need. Yeah.
Yeah, but but in some case, if publisher have that capability of defining rules for some subscribers, then publisher will indirectly be aware of the subscriber, what kind of subscribers are available in the system.
So that's there, but there will be for only specific set of subscribers. So it will not be for all the subscribers, but if there are subscribers who do not want to process certain data that is outside, then they can provide this authorization. Again, it goes back to the business needs, right? As a publisher, I don't need to know about the subscriber, but there is a need for me to enforce authorization for a set of subscribers. Then that capability is also built in. But you are right in saying that the publisher will know about the subscriber if the rule needs to be provided.
Yeah, sure.
Maybe it's just about the attributes of the subscriber, right? Not the exact client ID or anything, right? You define policies for subscribers who satisfy certain attributes, right?
Right. Only for a set of subscribers.
Yeah. So in that case, it's the publisher is not directly coupled to a particular subscriber, rather than category of subscribers.
I think that just sharing this use case that we had would make it clarify a thing. So in TechOps, in ThoughtWorks, there are these applications that are built for all ThoughtWorkers across the globe, and then you have got this regionality, India regionality, China regionality, Brazil regionality, and so on, right? Each of these regionality teams build applications for their own regions. Like in India, we have India Leave application, right? Similar to that, each country. China, they do some WeChat integration and so on and so forth, right? So in that context, when you think about that, if there are some events that happen in people domain, essentially we're talking about some employee joining or leaving or other events, right? Who can receive these events? And especially in a world where we operate, we are expected to comply with GDPR considerations, and of course we have this MNPI, which is related to the stock market related considerations and so on and so forth, right? And that's where like the PA is a good example Satya was talking about, right? So a regionality application can receive events that are related to the employees who are from that region, right? Not the employees from other regions and all, right? So it's just one use case. Of course, there are a few other use cases as well. But essentially, this kind of use cases essentially means, we are talking about a fine-grained authorization at event delivery level.
Any other questions? Cool. If there are no other questions, then we'll close for today. Thanks a lot, Shaktidharan, Sabarish, and Saktivel for the whole presentation. I think many have liked it. And it was a very, very relevant topic for all of us to discuss today. Thanks a lot for making it happen. Thanks everyone for joining, and we'll see you next time.